Hello, everyone, and welcome to the Office Hours Podcast, episode 74. Today, we have a pleasure of having my good friend Yurii. We've met Yurii a bunch of years back. I think it might have been an Erlang meetup, probably close to like 20 years ago. So we were kind of revolving in the circles of Erlang, Haskell, FP, all the fancy things that are happening around those times. DevOps, quantify itself. Yeah, the meetup scene was kind of crazy at the time, but I guess you can tell a
Yeah.
little bit more about that, Yuri. Welcome.
Yeah. Hey, thanks for having me. Pleasure to, chat. I've been following your podcast for a while. I think from the very first day you started, I couldn't say I watched all of them, unfortunately, but I'll try to
That's fine.
catch up one day.
Yeah, no,
Um,
no.
yeah, but I think you're right. I think we met around the Erlang community, and I mean the whole Vancouver scene of tech and programming and everything around that. I think that
Hmm.
was the environment that was kind of conducive at the time for meeting people that are interesting. Um, yeah,
Yeah, it kind of, there was, the meetup was a brand new thing. There wasn't such a thing even before. I think they were basically first. I think the whole verb kind of came, I mean, obviously it's generic enough, but like the whole concept started with meetup.com. And they were playing around with their monetization model. And I remember like a whole bunch of different meetups just sprung up, kind
hmm
of seemingly out of nowhere. And I used to live downtown around that time, and most of them were hosted downtown, so it was like really easy to make all of those and meet a lot of cool people, and you kind of see the same faces across all of them. So there was like this big community. And then eventually, I think it kind of collapsed into Polyglot, and I don't think the polyglot's been happening for a couple of years now. I don't really think that it's gonna be continuing, unfortunately. Which was
yeah.
like
I'm
the
not aware either.
yeah,
As you know,
yeah,
I'm on Vancouver Island now, and we
yeah,
have our
yeah.
own meetups here.
We should uh we should ping some of the original people like Chris Nicola or something like that. But I guess he's too busy with his own company to organize that
Fair,
stuff. I
fair.
imagine it's a
But we
lot of
should
work.
have something, for old time's sake.
Yeah, no. Man, COVID really thrown a huge wrench in the whole thing. I think they did like polyglot right after, but the turnout was really low, and I think a lot of people kind of lost their habit of even going to those things. So sadly, it's not happening right now. Other things are happening though. I've been at a security conference a couple of days ago. The that episode, by the time this is released, that episode should also be released, which was pretty interesting. And I'm also going to B-Sides. I was kind of debating whether or not I want to go to B-Sides, which is another security conference. And in the end, I decided that I should just make an appearance because I've been going there since 2014. It would be a waste to break the tradition, I guess. So yeah, we were kind of hanging around in these esoteric non-mainstream languages, and I only went there because I was running some software based on Erlang. I think I was running my own Jabber server, which was running off of Erlang,
Yeah.
eJabberD
Jeopardy. Yeah, I remember that.
1.4. Yeah. So I just kind of had this generic interest, and I remember you were doing some cool stuff around crypto around those times,
That
and
was, I think well, I started the Erlang meetup before that.
mhm,
So I started attending it, and then I was organizing it, I believe,
mhm,
for a little while. But at the time, when I was in Vancouver downtown, and obviously was engaged in a lot of this stuff. What I started with, I was trying to build a competitor to Heroku, but for Erlang. So
mm.
specifically, that just basically take that model, but instead of say Ruby on Rails or something like that, you would have Erlang with all its capabilities. And the company was called Spawngrid. And
Oh right,
obviously
I
from
remember. I
yeah.
remember. That's right, Spawngrid.
Yeah, and so Spawngrid tried that. We didn't quite get anywhere really. It was just a little bit up and down. And it got some government grants for some projects that were interesting within that whole concept of
Yeah.
first Erlang and then actually testing, like property-based testing, because it was a big thing in the Erlang space as well.
Yeah.
So it
It
was
only
interesting.
started spreading out into like other communities way later. I remember like at the final days of Haskell meetup, they did like a big thing about property-based testing, but that was probably like 6, 7 years after, the original Erlang meetup. So a lot of these things,
right?
I think people just weren't ready for. People weren't really ready for Erlang. People weren't really ready for those things. They're like pretty
Yeah.
happy with like PHP and Java. So when you tell them about Erlang and its quirky syntax, they kind of just went like, "Huh?"
Yeah, and actually, so Spawngrid, didn't work out in any of those ideas, and eventually it pivoted to this Bitcoin exchange as a
Bex,
service, Bex. Bex was basically the continuation of Spawngrid. It was still built using Erlang, well, Elixir in that particular case, but Spawngrid has been using Elixir, not from the very beginning, but fairly early. I was one of the core contributors. I think I'm still in like top 10-ish contributors to
nice.
Elixir, but I haven't touched it in like more than 10 years. So it was kind of in and out.
Yeah.
Great experience though.
Yeah,
Um,
if you
yeah.
haven't been able to tell, Yuri is a an entrepreneur and a hacker extraordinaire. He's doing things that are like way advanced compared to myself. I always look up to him and it's like, okay, what sort of crazy stuff is he gonna be doing next? But sorry for interrupting. To go
No,
on.
no, no worries. I mean, crazy is the right thing. The problem with crazy, it doesn't always work out.
Yeah,
But it's kind of encoded into the whole notion, right? You have to try things, and you'll probably fail most of the time. And
yeah,
I feel
yeah,
that way all the time. That it's always sort of straddling that line between crazy that will work out and crazy that will not work out, and usually does not work out. But you just have to try.
yeah. It's basically like that quote from that Russian science fiction from Strugatsky, which was I don't remember exactly how it goes, but it was something along the lines of like, why would we care for looking for answers to solvable problems? We already know they're solvable and will be solved eventually. So looking to
Right.
answers for unsolvable problems is a much more interesting endeavor.
Uh, I don't know if I'm looking at problems this way. I look at them from a perspective of what would be interesting to do, as in just really serving my curiosity,
Mm-hmm.
just trying to figure out like what will happen if I do this. And sometimes that's dangerous if you're doing something more than computers, right? That leads to things exploding usually. But the computers. Sort of variant of that is usually not very explosive. I mean, you get crashes and stuff,
Yeah,
and as long as you're not doing something
yeah. You
mission
can
critical,
occasionally format your entire hard drive. I
right?
haven't done that accidentally probably since 2000s or something, but I did do that a couple of
But
times.
it's the very definition of undefined behavior, right? It might crash, it might format your hard drive, one of those things. Um, but definitely, I think following that path is always interesting because you always find something that you had no idea about or just never had attention on something, and this way you just discover something. Think I've discovered most of the things that I'm enjoying now or enjoyed at some point, and something that generated value for people by doing pure experimentation. you
Like
know
pure R&D.
yeah, it's kind of like hold my beer type of thing. Like it's just like what if, just the what if.
Yeah, yeah, yeah. I don't know if you've seen, if you follow, probably not, but a fellow basically recently presented this thing where he ported the Doom engine onto the TypeScript type system compiler.
Hmm.
And he kind of started it saying, I just wanted to do like a quick and dirty proof to prove that it cannot be done. And then eventually it's like, I can solve this problem this way and I can solve that problem that way. And like a couple of years later, he actually managed to create essentially like a VM that can run Doom on the
Hmm.
compiler types. So it's not even the compiled code, it's just the compiler like figuring out types. He says that it takes him about 12 minutes to render one frame, but it works. And it was just all like, what happens if I'll do this?
Right.
Like, can it, is that thing even possible?
Hmm. And in fact, what I'm working on right now kind of came out of an experimentation like this. I mean, I've been always trying to understand the relationship between, the data that we use and, the data modeling, the data structure, and et cetera, that we use in our business systems. But when I started the project in the company, well, at the time it was just a project, wasn't company yet. When I started Omnigres, the hold my beer problem was, can I have a web server inside of the database?
That's an interesting thought.
And obviously, most people say, why would you want to have that?
Yeah.
But that wasn't really the big question that I had. I mean, I had ideas why this is great. and I can expand on that later. But
Right, right,
the first motion to actually implement that was just like, can I just try? Like, if I take Postgres and sort of bolt on a web server,
like would it
what
even
can I do
work?
with that? Right. Well,
Right,
first,
right,
will it work? Like, what do I need to do to make it work? But then when I do make it work, what can I do with it?
right.
So that was the initial
Wasn't there
push.
like wasn't there like a I remember a bunch of years back there was like some talk about like a kernel mode HTTP server in Linux or something like that, or am I misremembering?
I'm not sure, but it sounds like it's something that could have been done either as a like loadable kernel module
Yeah.
or maybe
I doubt
something
that
eBPF
Linus
based.
will ever let people merge that stuff into the
No,
main line, but I think there was something. It's like we have like kernel mode, some HTTP thing for whatever weird reason or another.
right.
But so you managed to bolt on a server into Postgres and effectively allow access to Postgres's internals through like a REST-based API.
Well, any kind of HTTP or WebSocket API. So basically, just web server. Think about it as if you just collapsed your backended database into one single entity.
Mm-hmm.
Where think of Postgres plus Omnigres stuff as a big backend that
Mm-hmm.
happens to have a database inside, and that particular database is not SQLite in that case, so just a library, but it's a whole Postgres system with replication and all the extensions, all the functionality that comes with it.
Mm-hmm.
So it's just a collapse of that. Because if you think about it, most of backends, what do? They get a request from the browser or API user and kind of shuttle it to the database
For
most of the
most
time.
part,
For
it's
most
they just like
parts,
an intermediary. Yeah, they
right?
sit there and
If you
really
remember that
not do that much.
the Office movie,
Yeah, yeah. What is
remember,
it that you do here?
right? Well, I take the requirements right from the users, and so I felt kind of the same way about backends because they translate HTTP into essentially SQL queries.
Yeah.
And then they interpret the results back from the database
Hmm,
and
hmm.
spit out whatever they need to spit out: HTML, JSON, XML, if you're old enough to remember that part. Uh,
Soap and Corba.
right. So the idea was like, why do we need that middleman? And
I
so
guess it
can't,
provides some utility because there is some logic that's attached. You may do some processing pre, post, may do some conditional things in between. But effectively, it is just shoveling data back and forth like 90% of the time. I think that's
right.
why Node got so popular because it's like, oh, we're waiting for the data to come back from the database, so we might as well serve a couple of more requests type deal, right?
Right, but I can also serve them, while it's working on. And what's interesting here is that people would say, "Well, you don't really want to do that because you're taking database resources to do some computation while you're preparing, to say issue a request." But the answer to that is kind of interesting because if you think about the HTTP requests, the sort of the timeline of it, you always want to compress it. You don't want long running HTTP requests because that's just bad experience for anybody, like for any
Yeah, well,
user.
because then you have to do these crutches as like Postgres connection pooling to make sure you don't spend time on opening sockets to your database backend, not to increase your like rendering latency and things like that.
Right, right. But what I mean is, in certain logic that takes too much time during the request processing is an anti-pattern anyway. You generally don't want it,
Mm-hmm.
because you want like a really, really short request response, right? You don't
Mm.
want just like go in and like wait for a long while.
So are you saying that basically like you throw a request and they'll say, okay, got the request, and then they stream you response over some other channel sometime later? Is that kind of the
Yeah,
idea?
like you start designing APIs differently, you employ WebSockets, depending on what you do. Like if
Mm-hmm.
something
Mm-hmm.
is effectively deferred computation, you don't want to sort of block it,
Mm.
whether that's um, a backend sitting inside the database or just a regular standalone backend. You don't really want that because it's, yes, it's okay to do that, especially on a standalone backend, but this is not a great experience for the users of the API or, of just the endpoint.
Right,
And
right.
so with that in mind, I realized that basically if I just go for data, in and out, in and out, in and out, I don't need the middleman. And so basically you can simply handle any HTTP request, either just raw HTTP request, or you can handle REST, because it's very, very easily
Hmm.
mappable to whatever you have in the database.
I
You
guess you
can do
might have some
WebSockets.
problems with like role-based access control if you just allow unfettered access over
Well,
REST.
you
So
don't, obviously. You
yeah, yeah,
obviously
yeah.
don't. And so this is actually an interesting, somewhat counterintuitive topic to some people. Because if you think about it, usually the way we organize access of backends to the database is that unfettered access.
Yeah, like the backend sees everything,
Right.
and the backend decides which clients get to see what a lot of the time.
Right. But if you look into other projects, like for example, there's this project called Postgres,
Hmm.
one with T
It's
at
like
the
a
end.
REST wrapper on top
Right.
of Postgres.
It's a
Yeah, yeah.
simple backend that sits sort of between the browser, or rather API, consumer
Hmm. Hmm.
and the Postgres database. And the way it enforces security of your data, that is, you can't see what you're not supposed to see. You can't modify stuff you're not supposed to modify by forcing you either define views, like updatable views over your tables. So you only can access certain schemas
Hmm.
with that,
Hmm. Hmm.
or by using row level security policies.
So like basically built-in Postgres authentication mechanism with like row-based access.
Yeah,
Yeah, yeah, yeah.
right. And so basically, we're doing the same thing here.
Hmm.
We're saying instead of backend having unfettered access, then it can, simply forget a rule, that you can't see that, you can't
Or if you get
see
hacked.
this. Yeah. Basically, it's interesting because if you think about it, a traditional backend is always subject to security review. That is, if we have say, a highly regulated or otherwise sensitive system, and you make changes to it, and your backend is responsible for ensuring that you only give access to what they are supposed to get access to, then every single change, so every single pull request, has to go through security audit.
Yep.
And that's it. Like there's no escape. However, if you maintain your rules, or like row level security policies, the views in a singular location,
Hmm. The
you can
closer
say
the
that.
closer to the actual data it lives, the better, basically.
Right. And
So
so
if it can
basically,
live on the data itself, that's like you can't go any closer.
right, the database will enforce it, but also for us as, people who write systems, we can say, hey, we don't, if we didn't touch this part, that means we have not changed anything about the access policy.
Yeah,
Therefore, this particular change is not subject
yeah,
to access audit.
yeah. That's an interesting selling point, but yeah, that's fair, very fair. I guess it makes it like, does that mean that now your principal that's accessing your website and through the website accessing the API, does it mean that that person's credential is essentially tied to like the row-based principle in a database? Because that would be the only way you can really achieve that.
Not, no, not
Not really?
really. So it's not mapped to, say, roles as they call them in Postgres. It basically, what it does by putting that application server inside the database, I can actually set the current session.
Mm. Per
'Cause
request?
yeah, every time I'm processing a request, I effectively, in the scope of that request, I can say, this is the session. These are associated sort of elements of that session.
Mm.
For example, user, say user
Right.
ID or its role, whatever, and whatever policies I have, either through views or through role level security, they can use that.
Mm-hmm.
And that's actually a
Interesting.
very flexible mechanism. And this is very difficult to do in a standalone backend because
Yeah.
the information about who is accessing
Is separate
and the
from, yeah,
database
yeah,
are
yeah.
separate, so they need to be communicated back and forth.
Yeah, I've seen some crutchy examples where like whenever you connect, it would the ORM or whatever system would run like this preamble where it would like create some internal variables and like set them as you begin your session, be like set at current underscore
Hmm.
user to principal name, and then if you have like stored procedures that can reference that global variable session variable,
Right.
it feels kind of clunky. But I guess your system, you because you're living in the Postgres, you're not in front of their authentication mechanism like for the connection level. You're kind of next to it, so you kind of have to re-implement a bunch of that stuff yourself. No?
No, it just basically this session management mechanism provides a basically tools for you to
Hmm.
use for your access policies. So in these access policies, you can check what is
Hmm.
the user ID or what is the
Right.
user
I
role
guess.
as per your sort of domain.
Yeah, I guess now I'm thinking like normally if you have a separate backend and a separate database and there's like a database credential that the backend is using to communicate to the database, usually there's just one. You just have your PG pool, whatever, you give it a username and password, and then everything goes through that same pipe. However, whatever roles that user has, that's everything you can get. So maybe like if you have a read, not even read replica, maybe you have like a read only account for read side of your API. Even if they compromise that credential, like they cannot modify the database. But then if the code that's running inside Omnigres, because it literally has access to everything, it provides, if they manage to break into it and compromise it, it provides like access to literally everything. So I don't know. Any thoughts
I
on
mean, not
that?
not exactly actually. So you can enforce the basically the user that will run the functions that are executed. So you can actually
Mm,
set the security to be basically to run under the um, particular credentials or particular
mm. So like
Postgres role.
security by caller or whatever it's called.
Yeah, it's basically we define, the constraints. Like you should not run this as a super user.
Mm, mm-hmm,
That's
mm-hmm,
just not a good idea, obviously. So you still limit which Postgres role you should be using, and
mm-hmm,
then within that you have the access policies kicking in
mm,
and looking into your session and saying, oh, okay, so you have user ID such and such.
mm-hmm,
Therefore, we'll
mm-hmm.
filter out whatever you're not supposed to see. We'll filter out whatever you're not supposed to edit. That's how it does it.
Interesting. That's very cool. I kind of have this thought in the back of my head is like, I wonder if the capabilities access model would work with the system where, like you issue a request to your system, like maybe the very first thing you call to your system is like, okay, I'd like to authenticate. And on the response, it gives you like a list of capabilities. It gives you like a list of the one-time use tokens in terms of like, these are the actions that your principal can undertake. And if you want to call them, you have to use those tokens. And once those requests complete, it gives you another set for the next time. So like it's very, very like
It's
delineated.
very doable, and in fact, this is very compatible with what we have, because you can store these tokens in the database right there, right? So
Mm-hmm.
you have the persistence level sort of there,
Yeah.
right there, and so you can issue those basically
Yeah.
by inserting and returning them to the user,
It's
and
kind of
then
kind
with
of similar to like AWS tickets for like uploading or downloading things from S3. They're like timed and signed. So you have like a certain window
right.
or maybe no window, but like you have this signed credential that is like maybe used X number of times or maybe used during this period of time. So it's kind of along those lines. I don't know
It
if
is
that makes sense for
along
business,
those
but
lines, yeah.
I think it's
It
pretty
it
cool.
does make sense. The pre-signed credentials are great, except for the cases where you need to expire them
Yeah,
before.
yeah, that's a pain.
And at
That's a
that
pain.
point, basically saving them in the database is actually easier.
Yeah, yeah, yeah.
You can
It's
still sign something about it, so just they're not as guessable, but
yeah.
there are many ways to
It's
achieve
it's a whole
that.
session versus jot debate once more.
Right. And it's actually a great point, because I was rereading some of the documents. I think there was a booklet by Redis, and they were explaining how they're a great store for like those jot tokens, right? And I'm like,
It's
yeah, but
like
the whole thing started because we didn't want to do the round trip to the database to maintain the session statement, right?
exactly,
And now we
exactly.
need to do this invalidation. So now you do have a database that is your,
So you're
invalidation.
effectively re-implemented sessions only with more steps.
Right, way more steps. And I'm like, well, if I don't have the round trip, then it's actually all right, because that database becomes very simple. It's
Yeah,
it's a
I
table
guess
you
that
join
that
with.
little round trip actually shrinks to almost nothing. It's like nanoseconds to just do some access here and
Right.
there.
And it becomes so much simpler. I don't
Yeah,
need JODs. I just need the session ID, and I'll just
right, right.
find by it.
I think for capabilities, it's probably not that big deal in terms of expiry because they would be valid only for that session. So if somebody somehow manages to obtain it and they connect from another connection stream, those would not be valid in the first place. So it's not.
Yeah, very easy to tie them in. And again, you don't even need to expose this in any encrypted or unencrypted way, or like
Hmm.
signed way. You simply store that information in the database and
Yeah,
you're good to
yeah, yeah.
go. Databases are good, and I think people are generally afraid of them. That is, developers. A lot of them are afraid of databases.
Do you remember that 15-year-old cartoon about how MongoDB is WebScale?
I do. Yeah.
I think people are just kind of like, oh, Postgres and RDBMSs, they're so yesterday, you know. I guess there was that period. I think now it kind of probably the hype curve inevitably leveled out. But I remember the time where I was like, Postgres, oh man, we use Redis or we use Mongo or we use whatever. I still have like a React sticker on my laptop somewhere, you
Right.
know. So
Yeah. I think this whole NoSQL notion kind of died down a little bit. Obviously, there are still a lot of users, but as with every hype curve,
mhm.
it goes up and then it goes down. Everything goes through that curve. But I think what's happening right now, people started treating databases as these sort of boxes that you put data in and retrieve data out of, and it's sort of a service that sits somewhere over there in the corner of your infrastructure. It's very
Mhm.
important, but it's a different thing.
Yeah, yeah, yeah.
And people don't really understand fully how it works. I've had a lot of conversations with application developers, and the level of understanding and the level of comfort with, say, SQL or stored procedures is very low,
It's been
and
on a
it has been going
decline.
down,
Yeah,
and it
yeah,
has been
yeah.
going down. And I think part of this is just perception. I mean,
I
obviously,
think I think ORMs made it way too comfortable to not have to care about these things, so people don't.
yeah,
But they
I
miss
think,
out
yeah,
on a whole bunch of things that you can do that you cannot do without ORM. Or sorry,
right.
rather, you cannot do them using an ORM, but you have if you go raw. There's this guy that I follow. Uh, I think he's the creator of the Fira Code font. So you
Hmm.
probably heard his name, Tonsky,
Oh
and
yeah,
he
I
he
follow
he
him.
yeah, he has a Telegram channel, and he recently posted about like, why do we need all these intermediaries? Like, why do I have to write some code that then converts to SQL where I can just like write the SQL directly? Like, what's the whole
Yeah,
point, right? He's also
that
old
whole
school. Yeah.
yeah. But I can see that, and it's actually a very interesting thing that I found when I started talking to people about this. I found sort of three groups of people in, I guess, on a scale of their experience and expertise in the industry. And I found that basically people who just entered the whole industry and are working in roughly the same space, that is, creating line of business systems,
Right.
they get very excited about what I'm talking about. They're like, oh, this is interesting, because they have a lot of this curiosity, I believe.
They don't have a lot of preconceived notions that you tend to
Right.
carry for all these years being
They're
in this
still in this
business.
absorption phase, right? They consume and learn, and this is great. But then it kind of this curve goes up, and the term I use for this is the confidence curve. So your confidence grows, and so at the top of that curve, I find that people reject the ideas that I talk about. They're like, I figured stuff out, and you should be doing like TypeScript or this or Mongo. It doesn't matter, something, right? And they're
Yeah,
just
yeah, yeah,
like,
yeah.
I'm very
They have a
productive,
prescription for you.
right? And I mean, it's working out for them, generally speaking. There's nothing bad about it. They're very productive. But what I find is that after that, the people who kind of slid off that scale, because once you learn a little bit more, you understand you actually don't really know much. You basically return back to that phase where you're
As
like,
as you started, I was immediately thinking about like the Dunning Kruger effect. You know, like it's like, oh
uh,
yeah.
right. So I found, unsurprisingly now in the hindsight, that people my age are generally very receptive to this. Not
Hmm.
everybody, of course, like, it's okay, but it's the young people and sort of, I don't want to call
Seasoned
myself old.
developers.
Yeah, I don't want to call myself old. So uh, people have been around, and they often seek that simplicity. And so we have created a lot of stuff, and some of this stuff in the industry is amazing, but sometimes
Yeah.
it's just created
It's
too many
yeah,
abstractions.
it's people who are way past the enterprise fizz buzz stage. You just want something simple and robust and tiny and without a lot of hoopla. And like I'm in the same bucket right now. I look at all the layers that we've managed to create for ourselves and all the problems that these layers are causing us. I'm like, man, it used to be so simple. Why can we go back to our roots? You know?
And this is, I think, a great question. Why can't we, right? And obviously, there's a lot of inertia. Like once there's this train, going, you can't really derail that train and send it somewhere else. Like let that train go whatever it goes, right?
Yeah.
But I think the only thing we can do is just continue embracing the ideas that we have, and some of them will work out, most of them will not. Um, to give you an example, actually, just before I started Omnigres, I was trying to see the same problem that I have with software design through a different lens. So what I wanted to do was kind of way too grand in terms of scope and in terms of how much time and money you would need to build something like this and to promote it. But what I was thinking about was, if you think about it, what is our foundation that we use today for running these business systems? People usually start thinking about maybe the whole web stack, languages, etc. But we rarely think about the operating system underneath.
Mm.
And obviously, most of the time it's Linux or something like that, FreeBSD for some, Windows in some cases, but they're all roughly the same. They're just some differences between them. But the thought that I had was, if you think about it, the abstractions that are implemented there, they're not for this era. They were essentially conceived in, let's say, 70s, just
Yeah,
for,
like
for rough
origins of
measure.
Unix, effectively.
Right. Where you had these big computers, relatively speaking, serving multiple users and serving, basically slicing the resources of this computer and serving them to these users. But this is not really how we build big systems now, right? But we still sit on this foundation. We
Hmm.
still say, well, there's memory allocated in the kernel, there's file system, and like people get so hung up on um, using these interfaces. Like, for example, how do we make sure that this works through the file systems that we have? Because
Hmm.
file systems
Hmm.
can be different, and why kernel is not
Yeah. Well, I mean,
doing
I
what
mean,
it's
they
supposed to
they
do.
made a lot of things to kind of speed it up. You have like memory mapped I/O and all these other things to
Yeah,
kind of solve these issues purportedly.
but if you think about it, file is just an abstraction. Files do not exist. It's just a concept that.
There is no spoon, Neo.
Right, I know. But if you think of it, it was just an abstraction. It's, well, let's say it's, it's a certain interface, right? It has a name sometimes it doesn't really, right? But it's basically something you open and read bytes from, write bytes to, right?
Hmm.
It is an abstraction,
Yeah. It is kind of a stream like any other stream, right?
right? Uh,
Which is,
but
I
I
guess, what
was
the whole point of Unix abstraction was. It's like, is it a file? Is it a socket? Is it a TCP socket? Like, who cares? It's just a handle. You just read and write from it, right?
right. But that was an abstraction that was really good for that time, right? And that
Hmm.
was what, 50 years ago or something like that,
Pretty much, yeah.
somewhere there. And what I was trying to research and still, find myself thinking about this at times, what are the right primitives today
Hmm.
for building systems? So, for example, we know we want to distribute our code. So, for example, map reduce type of behavior, like, we just want to apply this function to so many things, right? We want to store stuff in a certain way. We want to optimize software so that whatever capabilities of the CPUs that you have, on premise, you can use them. And it's a very big topic, of course. Like, it's hard to cover anything here, but think about things like this. What if and we're returning to the what if part.
Right.
Uh, what if an operating system, or however you would call that, had a very basic primitive of a transaction? Like, everything was transactional.
Hmm.
Because operating systems that we have right now don't really have that.
Not without a lot of weird
Right.
crutches. Yeah.
But think about it, like, if basically, what is an operating system anyway? It's basically a library of a sort, with some background processes, right? That gives you some primitives to build stuff on.
Hmm.
And so the question was, what are the, like, if we basically had the mandate, the money, and whatever to just throw out POSIX and everything around it, and say, what are the primitives that we actually need today? Forget the fact that we have so much software already running. It's just irrelevant or immaterial to this research.
Yeah.
How would you
Yeah.
design it today? And
Yeah. That's an interesting question, because there's a couple of like interesting operating systems. Some of them probably will never see the light of day officially. I don't know. I don't know if Plan 9 uses different abstractions compared to like POSIX style. There was another interesting operating system that I read about like 10 years ago and haven't really read anything about since, so it's probably dead, which was called Phantom. And they
Mhm.
had the whole thing with like memory snapshotting. They had a lot of really interesting concepts that like never really were found anywhere else. And another crazy example I brought up on a couple of episodes ago recently was Temple OS. You
Mm.
know, I don't know how much you looked at it, but that
Oh,
guy did some
I
crazy
have
things inside. Like you can literally like in your console you can just type C code and it would compile right away and like give you the results. So your
because why
shell was
not?
basically a C compiler.
Well, it's a holy C compiler.
Holy C compiler. Well, fair enough. Holy C compiler. But there was another thing that I was thinking about. Have you heard? You probably have, but what was it called? Erlang on Zen or Erlang on KVM?
Yeah, I
Where you
actually
effectively have like a
know people who built that. Yeah,
yeah, you have like the beam image, and then you just execute it on hardware effectively. So you get
right. And
like
there's like there's
server
this
start
whole
up 10 milliseconds ready to serve and it shut
right.
down immediately so you can like spawn like 10,000 VMs to serve 10,000 requests and stuff like that, which is I think is pretty cool.
I mean, it is cool, and there are also some other unikernel projects like Mirage OS where you just compile stuff in, or Include OS, which is a C++ thing, where
Is it
uh,
just all headers?
yeah, so so I think this is actually a great mental exercise for us to process what is happening with that research. If you think about it, and if you look into history, there was a lot more research that actually kind of saw the light of the day at a very different scale back then, of course. And then we still have this research happening these days. We just don't really know much about it. But what I think what is happening is we always go through aggregation, disaggregation in any market, in any sort of industry, right? There's always consolidate and do the reverse of that. And so we are in a very consolidated era right now. Uh,
Garbage truck.
yeah, that happens. Uh, and you can see that we consolidated on Linux. We consolidated. A lot of people consolidated, say, on JavaScript, TypeScript ecosystem, React,
Mm-hmm.
and in a sense, this is good because it simplifies things.
Yeah.
But the natural sort of pendulum, it's always going back and forth. Whether
Yeah,
it's
it's
good or
very
bad doesn't
cyclical.
matter.
Mm-hmm.
And so I think eventually we'll hit certain points where the motion will reverse in this particular area, and we'll see more stuff coming out. And then it will
Mm-hmm.
be too much stuff, and people will be like, "No, this is too much
This is
stuff,"
too
right?
much stuff. We gotta put it
Right.
all back. Yeah, yeah,
And it's
exactly.
all actually, these processes are happening in parallel, and they're all at different sort of stages. So,
Mm-hmm.
for example, if you look at the microservices movement, it's the opposite, right? So
Freaking
it's basically like
microservices.
spread everything out,
Yeah.
right? It's complete disaggregation. Whereas what I'm working on is complete aggregation,
Right. Yeah,
right? And so
exactly.
these motions are basically not aligned. And so you have to track, okay, in this particular band of things, where is it moving?
Right. I think people were excited by microservices. They just did not realize how hard distributed stuff is actually. Um, and the fact that in a monolith you're prevented from like 99% of dealing with the ugly physical real world and like actual like electrons flying around and latencies and speed of light.
Mhm.
But as soon as you start doing distributed stuff, everything is subject to those things. Like clock skew problems, stuff out of sync, like just stuff being lost randomly. Unless you like you build a bunch of microservices and then you read about cap theorem and you go, oh shit, we didn't think about that from the beginning.
I think, well, a lot of people in that community said that microservices were not really a technical problem. It was a social problem. Like, basically, how do we
It's like a
ship stuff
silo problem.
independently?
Yeah, yeah, yeah.
Basically, it
It's
was
that law
solving
law of
probably
engineering that
right.
the software design repeats the organizational patterns of the enterprise.
Right. And so basically by saying, oh, you don't have to ship a cohesive product. And therefore, like this team of three, this team of five can work independently of each other. They just need to publish the sort of APIs to each other. And fair enough. I mean, it's a good point. But I think it's not a point that is necessarily pointing us at the necessity to run independent servers, VMs, or anything that is completely delineating these things, right?
Mm-hmm.
But it's rather a conversation about modularity, right?
Yeah, in a
And
way.
modularity can be achieved in different ways. And actually, database itself is a great way to modularize
Yeah,
because
you
you
can.
can expose views
Yeah.
that are stable, over your tables, and just let the world,
Yeah, it's kind of like an API
interact with it.
endpoint if you think about it.
It is, but it's
Yeah.
actually more than an API endpoint because API endpoint is more of an sort of action, right? Basically, do this or get me that.
Hmm.
Whereas, say, in relational database design, it's essentially an assertion, right? A logical assertion that
Yeah, yeah.
in the world that we observe,
Yeah,
the
I guess
closed
when
world
I said
assumption.
API, I meant more like an API contract. A view is
Right.
effectively an
It is a
API contract.
contract, right?
Yeah, yeah, yeah.
And so it's interesting because now the way I use Postgres, in Omnigres, it's actually kind of microservice in a sense that you can implement your functions, even your views in different languages.
Hmm.
So you don't have
So
to,
what do
you
you
know,
guys support for that right now?
I mean, there's standard support for, standard things like, PLPG SQL, there's
Hmm.
Python. We have an improved support for
So it's like
Python.
essentially whatever Postgres currently supports in terms of running languages internally.
Right. We also have a prototype of a Prolog implementation.
Wow,
I started it 2 years ago. I didn't never really finished it, but it's interesting because it allows you to build expert systems on your data.
interesting.
Uh, and another
I told you this
example,
guy was crazy.
yeah,
Prologue.
another example of that, and I think the news of that will come out in about a month or so. But we're collaborating with another company. They have done. Essentially sort of a subset of Python uh, as the compiler. That is, they take Python looking code with some changes and compile it to a very efficient code.
Bytecode, yeah.
I mean, essentially going through LLVM and all that stuff,
Mm-hmm,
but
mm-hmm.
they produce very efficient code. And so we're integrating with them. So one of the languages that will be available will be sort of Python, almost one to one, but not exactly. But it allows you to do things like NumPy and things like that
Ooh,
right there.
ooh.
And here's a simple example: like the test we
Okay.
actually done it just yesterday. It's integrated, and you do a Fibonacci sequence in Python. Fibonacci of 40 on
Mm-hmm,
my laptop was taken about 10 seconds, I think.
mm-hmm.
Whereas with compilation included, which can be optimized out because it was just, the first version, it was taking zero point 0.3 seconds.
Mm. Nice.
And they have some primitives for parallelization, etc. So it's a very interesting project that they're doing.
Yeah.
And we talked together about this and we decided to bring it to Postgres because it's a great example of what we can integrate. And people can bring these numerical algorithms right there.
Yeah. No, that sounds really interesting. Actually, there was a thing that I saw today. It's been on my YouTube feed for a couple of weeks now, but I decided to watch it today. But basically, these guys are building this database called um what is it called? Time Space DB, I think.
Space time.
SpaceTime. You heard about it?
Oh yeah.
Yeah,
Yeah.
yeah, yeah. Because it's like their target audience is essentially like multiplayer online games where you just have like this global updatable state, and they basically compile stuff down to WebAssembly and then run WebAssembly code on top of their data. So
Hmm.
as you were telling me about these things, like before, I read about Omnigres and was like, oh, that's a really interesting idea. But today I watched this video and like a lot more things kind of started clicking in place. I thought like, oh, this is really cool, like for building massively multi-user real-time systems.
Hmm.
So is there like a lot of parallels between what you're doing and what they're doing, or is it just kind of overlapping domains a little bit?
I think it's kind of overlapping domains. I think with the limitations of Postgres architecture, we are probably not as well suited for the gaming domain. Although I've never
Mm-hmm.
really explored it, like I'm not an expert there
Yeah.
whatsoever.
Because I think they're
I'm
building the whole thing from ground up. They're
Yeah,
not
it's all in
literally
Rust, and it's
beholden to
just
any other RDBMS.
right.
Yeah.
We are, like in our case, very much beholden to Postgres architecture and limitations and whatnot. And one has to understand that Postgres is a 40 years old code base. I mean, it's getting always better. It's getting all the new features that people think of. There's a lot of money going into because, say, AWS, EDB, other companies, they employ a lot of people who work on open source Postgres, so which is great. It brings like optimizations, into the core, et cetera, et cetera. But it is still um, an older project with a lot of legacy, which is not necessarily a bad thing, but it's
A
just
lot of
something we have
stability, you know.
a lot of stability. And the thing is, they can't change things just willy-nilly because there's so much adoption behind it.
Oh yeah,
So you
yeah.
have to be kind of on a very conservative side. And this is where I'm actually very excited about extensions, and so are many other people I talk to. I personally think that a lot of innovation in Postgres in the next decade will come from extensions for that very reason. This is a place to experiment. This is the place to take risks, right? Something might not work out. Well, actually, like I said, a lot of things will not work out. But you got to try somewhere, and trying in the core is not the best place because yes, you can of course, take the core and
Fork
create
it.
your patch and fork it, and test it, even share it with other developers, and they will try it. But you will never be able to really test it
Hmm.
outside of, say, a small group of 10 people.
Right.
In order to really get it out to people, you need to make it easy to install in their systems. And extensions are achieving that, for better or
Right,
worse.
right. Yeah, it's much easier to install an extension into something you already have rather than having to, do this whole thing again with your entire infrastructure for sure.
Right. So basically, that's why I think, that's a great direction for introducing new capabilities, especially. And some capabilities will probably never make it into Postgres, like having HTTP server. I don't think that will ever happen. And I don't actually want for that to happen.
So you're building your thing as an extension, right?
Everything is extensions. Yeah, we have like 30 something extensions now. Um, they have different utility. Some are very low level, some are very high level. Like an example of high level extension would be a ledger. Like we implemented a financial ledger.
Hmm.
And so that if you have fintech kind of problem, don't think about it, just use that, learn how to use it,
Mm.
and you're done.
Yeah, I've actually seen recently there's like I don't know if it's based off Postgres, but it's like ledger specific database that kind of came on my radar like maybe
Yeah,
month and a half ago.
I think I know which one you're talking
I might have
about.
sent you the link about it because or somebody I learn about things. I don't remember what they're called. I just know that they kind of vaguely exist, and I never know where
Right.
to look them up. But it's like I remember seeing something like that, or maybe
No,
it's deja vu. Who knows?
no, I don't think it's deja vu. This is real. But I think I know what you're talking about.
It's
Is
probably somewhere in my GitHub stars because usually when I find something interesting like that, I star it and never really
uh
come back to it again.
Are you talking about TigerBeetle?
Yes, that's right.
Yes.
That's the
So
one.
TigerBeetle is definitely a very impressive but different animal. Well, insect, I guess, in this particular case.
Is it a
Uh,
tiger or is it a beetle? We gotta figure
right.
that out.
Uh, and I mean, they've done a great piece of engineering there. Like I'm like whenever I want to feel
Humbled.
well, humbled, yes, that's a great word, and also inspired. Uh, that's another word that comes to my mind. I go and read what they write, code, blogs, whatever. They've done an amazing job. Like they're very thorough, very methodical, very knowledgeable. But what they built is a very high performance financial ledger, like to the tune of like millions of transactions per second,
Hmm.
right? And
Like
it's an amazing
Visa and
piece.
Mastercard level of transactions ish.
Actually, more than Visa.
Yeah.
The numbers that I've heard about Visa were less than that.
But anyway, just to
So
kind of give
yeah,
people a sense of scale. Yeah.
right. And so when I talked to fintech companies, I went to Money 2020 last year, and most of these companies said, well, if you can do 5,000 transactions per second, that's plenty. And like that's basically to accommodate our growth too.
Mm.
So generally speaking, nobody except for the 5%, I guess, have the rate of transactions that is anywhere near a million. And the problem that I find with that approach, from my perspective, not as a generalized problem, is that it's still disconnected from your real database because all they do is essentially one table if you think about it,
Mm. Mm-hmm.
right? They record financial transactions at high speed. It's really, I mean, an amazing piece of engineering. But you start asking yourself the question, do I need that million transaction per second, right?
Yeah,
Is
no,
that a
that's a fair
requirement,
question. Yeah.
right? And in some cases, that is the requirement. And I guess that's their audience. But what I found,
Yeah, I guess like if you
through,
do some sort of high-speed trading type
right,
applications, yeah, yeah, yeah.
what I found is that a lot of times what is necessary is a different thing. And actually, they pointed at that in their blog, I guess, a couple of years ago. It's a very similar thesis to mine. They said that we are essentially getting destroyed by network round trip,
Yeah.
right?
Well,
And
that's why they like lay fiber lines to shave off time on their Nasdaq trades, to get an advantage financially. They
it's
even made a movie about it. I haven't
right.
downloaded it and haven't seen it, but I've seen
Yeah.
some bits and pieces on shorts about like these guys trying to like buy out all the properties in between to capitalize on
Right.
building that
But this
fiber
is not
line.
even, I would say this is network trip. What
Yeah.
we're talking about, like round trip, basically, if your transaction requires talking to different parties, right?
Oh, okay. I see what you mean. Yeah, 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 yeah.
That's the RTT comes in, right?
Mm-hmm. Mm-hmm.
And so their solution, the best I understand it, because I'm not an expert, obviously, in their solution, but I've read enough to have a layman's understanding, is that they're optimizing everything they can on their database. It's very efficient at capturing all that information.
Hmm.
Whereas what we have built here is an understanding that what is important is actually rules. So starting from very basic accounting rules, for example, like things should balance. Your assets,
That'd be good.
should be equal to liabilities and equities. So the simple formula, right? But then you start having all sorts of rules. I mean, you can come up with arbitrary rules. Imagine you're running a virtual credit card type of operation, and then for some reason you started looking into issuing credit cards to minors, like sort of dependent accounts. And then you decide, well, we shouldn't really allow them to spend, between the hours of 9 and I don't
Hmm.
know, 9 p.m. to
Okay.
9
Interesting.
a.m.
Interesting.
Just like to prevent, problems, etc. Buying stuff they shouldn't be buying, etc. So
Yes.
how do
If
you
your kid is stuck
implement it?
somewhere in the middle of the night, they can use the credit card to call a taxi.
Yes, no, but then it becomes more interesting. Like, what are they allowed to buy and what they're not allowed to buy
Right.
at that
Right.
time,
Yeah.
right?
Yeah.
Like emergency use, non-emergency use, and you need to make decisions about these transactions. And so if you have to talk to microservices about like, oh, is this a minor, right? Is this that? Can we do this?
Yeah. It's gonna take
You're
so long. Yeah.
Well, it's gonna take long. The information will get outdated. Some of it. I mean, this example is not a great example in terms of how
It's
outdated it is,
it's not outdated. It's eventually consistent.
right? But the idea was very simple. Hey, if everything is right here in this database, then all I have here is I'm enforcing this rule in the boundaries of this transaction. Everything's serializable, right? And I come in and I'm like, okay, I am joining with this table and this table. Like if this is wrong time, different type of count, non-emergency spending, decline.
I can't wait for Aether to do like a Jepsen series on your system. For those of you that don't know, he's a guy and he built this software to test all the different advertised properties of various like databases, distributed and not. And usually there was like a lot of debunking of a lot of marketing bullshit on a lot of these databases. It has been doing it for years, and a lot of them actually, to their credit, have managed to like resolve a lot of those issues. But it was a really interesting read when he just started, because it was just destroying various products that were super hype at the time.
Right. I think it's actually a great effort, and I think this is the only realistic way of doing that, because it's very difficult to do something like this from inside.
Hmm.
Because questioning yourself, in theory, yes, very doable. In practice, you can't see what you can't see.
Yeah, you need external perspective on
You need
this.
an external perspective. You need somebody who's also very focused on this. And so I think retaining people like this, even early on, and basically running your designs by them can
Hmm.
be useful so that instead of getting destroyed on the internet, which is
Well,
everybody's
I think
favorite pastime.
yeah, like Jepsen is basically, I think they're running it as a consultancy now as well,
Yeah,
so you could do that.
yeah. I mean, it's probably not cheap, but
It's probably not,
everything
but
good is usually not
yeah,
cheap.
exactly.
Um, and there's also another company that has made a lot of waves recently, like this year, Antithesis.
Mm.
They even ran a conference just like a week ago, I believe,
Oh wow.
Backbash. So basically, they do sort of um, it's not property-based testing exactly, I think, but it's basically deterministic testing. And so they
Mm.
have these, I'm not sure how they call them, deterministic or non-deterministic VMs, but basically they just simulate scenarios that are nearly impossible to actually reproduce uh,
Mm.
by yourself. So they run your code in specialized VMs, introduce delays that are actually not as long or anything. So basically they
So it's like a chaos monkey on hardware level.
yeah, and well, it's not hardware level.
Well, it's
It's
not hardware
still
like
software.
VM, but
Yeah,
simulated. But
right,
from the point of view of the thing running, it thinks it's running on a hardware, but that hardware is being really quirky, is what I'm
right.
getting
And
out
so
of
like
this.
networking, etc. And so this comes from guys who developed Foundation DB that
Okay.
was acquired by Apple a bunch of
Mm.
years ago. And these are again very, very smart people that I always look up to because I'm not anywhere uh, as smart as they are. But this is amazing stuff. Like I had this introduction to some of the formal methods and semi-formal methods like property-based testing, but this stuff is usually, I mean, I understand it, but it's like at some level I understand it, but to implement something like this, it will take quite a bit. And in fact, what's interesting about this company, they've been around apparently since 2018.
Oh wow. Not that long.
They, well, I mean, they've been around. That means well, they announced
7.
last year, so like
Yeah.
6 years. They were essentially in stealth mode,
Yeah, yeah, yeah.
acquiring customers, having no website,
Right.
and it's interesting because even with all those smart engineers and everything, it took quite a few years to flesh it out, right? And it's interesting.
Man, you're gonna make my imposter syndrome flare up because it's like, if I'm not as smart as you, you're not as smart as those guys, then what that makes me?
Oh, by the way, this is a very serious problem, right? I
Hmm.
mean, a lot of us do have imposter syndrome. I mean, I have it every day. Every time I read something, I'm like, oh, like
It's
what am
like,
I doing? Just like, what am I doing?
yeah, yeah,
Uh, but then think about it this way: there are just so very few really smart people,
that's true.
and if we only let them do things, they won't be able to sort of keep
To
up
do it all, yeah,
with the
that's true.
demand for them, right? So
Yeah,
it means
yeah.
less smart people like ourselves
We
should
can
do
still do
something
cool
too.
things. Yeah, that's
Yeah,
true.
we could
That's true.
just on our level, like you probably can never reach that imaginary level that you have in your head, that you're putting some people into that sort of basket and you can't be there. Or
Mm.
at least you think you can't be there.
No, you just
But
need
you
to be
still can be
happy with
here.
yourself. Like,
Right. You can be here.
comparison is a thief of joy, as they say, and comparing yourself to
Exactly.
other people is a really bad way of living your life. You
Yeah.
should just compare yourself to yourself from yesterday and be satisfied with that.
True, but I still
Yeah.
compare myself,
Oh no, I
my
mean
work
you
to
you can't
others.
you can't help not to. It's like an ideal state where you don't do
Right.
that, but we're all fallible ultimately. How are we for time, by the way?
I'm good for now. Yeah, like we can still
Yeah,
go a
okay.
little. Yeah.
Right on. Well, there was this other thing. Oh yeah, I was thinking. I remember talking about it, but sometime a couple of years ago, we were building a system, and I remember adding real-time components to it because Postgres has like a built-in pub/sub system that not many people know about necessarily. And I remember building this chain where I would have pub/sub inside Postgres, and then it was exposed over like a signaler because I was using it in .NET infrastructure, so it was exposed all the way to the front end. And then whenever you ran certain queries or certain, the query like inserts into some table had a trigger on it, and the trigger would publish something onto the pub/sub. So whenever some data was written to the database, that was immediately kind of available on the front end through that whole chain. And I thought that was pretty neat. It wasn't particularly crazy engineering, but it was pretty neat nonetheless. So like I was thinking when you said like you have WebSocket support, you can essentially notify things being changed in real time. So like if I have an option, if I have a connection open to the system, and I queried some information internally, you could potentially keep like a list of all the things that I queried, and if any of them change, you can like immediately notify me over like that WebSocket straight out of the database. And I think that'd be
Yeah,
pretty
I,
cool.
I mean, I haven't done exactly that, but just to give you an idea, implementing stuff with WebSockets is very trivial now with what we have in Omnigres. So, for example, implementing a chat like with multiple chat rooms and stuff is very easy. All it
Mm-hmm.
is basically write the message into the table. There's a trigger on the table that just goes and publishes stuff.
Mm-hmm.
And so usually the implementation is like yay long.
Yeah, yeah. Like the
Uh,
implementation was not that big when I did it.
right. But it's
I
just,
think eventually,
in a
if yeah,
box,
eventually they said that they can't really deploy Postgres because it was like an institutionalized environment, and they switched it to Oracle, and that whole real-time component just completely fell apart. I was a little bit sad about it, but hey, what are you gonna do?
Yeah.
No, that is really cool. So how like is it available to kind of play around? Can I just download it on my machine and play around with it?
Yeah, there's a Docker container available right now. We're also working on CLI. It's been both fun and a little bit of struggle, but it's kind of getting there. Basically, that CLI takes that very same Docker image and
Mm-hmm.
basically gives you tools to automatically run, things like deploy your schema to the database, etc. Where we have still a little bit of a gap in how we capture the snapshot, like the revisions of your code and
Mm-hmm.
migration. So we capture them, but we are working on sort of next version of that
Like
because right.
how do you I remember the big pain with stored procedures is that they were always massively inconvenient in terms of version control because they live inside the database, and like you have to write a lot of glue and some kind of deployment mechanism to like store the actual version source code in Git and then push them somehow through some kind of migrations over in your
So that's
DB.
exactly what we're doing effectively.
Mm-hmm.
So we've invested a lot of time and still investing a lot of time in schema management
Mm-hmm.
and went through a bunch of iterations and going through another one now. Uh, Basically, the idea is kind of interesting that we landed on. What we do is when you capture a revision, imagine that could be uh, it could be interpreted similar to git commit type of thing, but for the schema, right? You're capturing like this
Mm-hmm.
is a revision I want to capture, right? And what it does, we have a highly normalized schema for for the entire schema. So it's kind of meta
Mm-hmm.
schema. And what it allows us to do when you have a different revision, we can compare every attribute of every object, whether it has changed or not. Because they're highly normalized, we can say, this particular attribute of a function changed, for example, right? Or this particular thing about the table changed. For example, we had a column with this type, so the type has changed,
Mm-hmm.
right? And so what is possible to do there, and that's where we're heading, is basically a reconciliation process,
Mm-hmm.
where you have the schema, the normalized schema of what you have right now and the desired state,
Mm-hmm.
which is
Mm-hmm.
thing in the very same shape. All we need to do is basically join these, right? And for things that are decidable, like function changes, we
Are
just
you
change them.
taking a page out of NixOS playbook a little bit?
Not
Not
really.
really.
I mean, I've used it for many years, but the idea is very simple. Basically, look at what you have and look at what you want to have. And
Mm-hmm.
if you can easily compare them, and with highly normalized form, you can easily
Yeah,
compare
you just
things.
reconcile it. Yeah,
We reconcile, and so certain parts of these are basically undecidable.
yeah.
And
Mm-hmm.
this is where you write migrations
Mm-hmm.
in some form. There are
Because I
different
guess
forms.
like with migrations, there's always a problem of like how do you deal with like rollbacks and data loss? Like if you have destructive ops, like how do you recover back when you do downs? Like can you even do that?
That's a great question. The general idea here is if you want that and you want that done nicely, basically do only additive migrations.
Which is usually how it turns out in the end. It's like we can't risk deleting
Right.
stuff because that breaks way too much. and
Yeah,
that's
and then you can
non-recoverable.
have administrative runs where you basically trim that.
Mm-hmm.
Basically like once a month you just have this thing clean things up, right? So there's definitely that. But what's also interesting about this reconciliation technique, we found that it actually works for just about everything else. Like imagine you want to make changes to your cloud infrastructure, right? So there are tools like Terraform, for example,
Yeah,
or
yeah, yeah.
CloudFormation or whatever, right? And they say,
Pulumi,
well, your
whatever.
infrastructure can be represented as code.
Yeah, yeah, yeah.
And our insight here was that actually your infrastructure can be represented as data. So you have basic views of what you have in your, say, Kubernetes cluster or in your like AWS account or whatever.
Mm-hmm.
Right now, it's basically just views working over HTTP calls, right? So they're querying what's there and showing tables to you. And then you
Mm-hmm.
have other tables that is your desired state.
Yeah. Well, it's essentially like what Helm does. It just like tries to bring you to your desired state with like least amount of
Right.
changes possible, more or
Except
less.
we're doing it with data. We're
Yeah,
saying
yeah,
like
yeah.
it shouldn't be code, it should be data. Because now you can join things and actually, build something out of your data. So for example, something changed uh, in even in your business data.
Mm-hmm.
That can bring a reaction to your infrastructure.
Yeah,
Like
no, that's
your
very
view
cool.
has changed and we have to reconcile it now, right? So we need
Interesting.
to change the infrastructure. For example, we say for every 1,000 users, we need to have a VM somewhere doing something, right?
Okay, yeah, interesting.
So this way, it's not a thing that you need to run like Terraform something, right? But it's integrated into your sort of world,
Yeah,
right?
I guess
World of
I
data.
might not see the whole picture just yet, but the gears are definitely turning. I'm starting to like visualize some possibilities there. Yeah, yeah, yeah.
Well, think about it this way. I wrote a post a couple of days ago on LinkedIn, out of all places,
I'll
that
link it in the description. Yeah.
if you think about it, there's only one database in the world that describes the whole world. It's just spread
Hmm.
out.
So
Like
you
we'll
mean
have like
the
little
world?
database, the world database, right?
Yeah.
And I mean, it would never be a singular thing, but if you look at the science of, say, relational databases, what they say is that we follow the closed world assumption, right? So
Mm-hmm.
basically, whatever is in the database, that describes the world, the way
Mm.
we know it. And so
Right,
every
right.
individual database just describes a very, very little tiny piece, maybe
Mm-hmm.
accurately, maybe not very accurately. Doesn't really matter. It's a world that it
Mm-hmm.
describes, except for a very small one. And so the composition of all these databases
Is
is
the
this
world. Yeah,
one,
yeah.
the world database with
Right.
a lot of overlap, a lot of conflict in information, but there is this, world database. And when you start thinking from that perspective, however ridiculous and sort of abstract that is,
That's very
you start,
esoteric.
it is esoteric. It's not really something that's really going to materialize, but it's a frame of reference. If you
Mm.
imagine that this whole world is represented by data, the world is not represented by code.
Yeah. I have to expand my consciousness a little bit more to fully grasp that, I feel. And then I see another problem with it. But since it's a fully closed system, we know from physics that in a fully closed system, the entropy inevitably increases all the time. So that's not a good sign.
Well, it increases everywhere, anyways. We're just following the world's lead.
Yeah, pretty much. Yeah. Yeah,
Yeah.
I had another question kind of unrelated to
Mhm.
this, but like how do you deal with stuff like multi-tenancy? Is it easy to deploy a bunch of applications side by side? Like do you can you like host them off of different interfaces on the same system or like I don't know exactly what I'm asking for, but that's what's in my head right now.
No, it's a great question. The short answer, I guess, is both easy and hard, depending on how you slice and dice the problem.
It
There are
depends, yeah.
even entire companies that are very dedicated to enabling multi-tenant applications on Postgres. Like there's a company called Nile.
Hmm.
They're very interesting. I know one of the founders. Very interesting company, very interesting technology. But basically, if you just abstract from that a little bit, it's a question of, well, basically what we're multi-tenanted for, right? Basically, do we want to write an application that has multiple tenants, or
Or
you
is it
want
like
to have
multi
multiple
applications? Yeah, yeah,
applications,
yeah,
right?
yeah.
So in our case, multiple applications are easy. You can have different interfaces in the same database and say use schemas to separate them, right? You can have multiple databases in your database cluster that is, a
Mm,
singular instance of Postgres, and they're just doing their own thing, interacting however they would interact if they need to at all. And then obviously the other side is how,
multi-tenancy for single
multi-tenancy.
application. Yeah,
Yes, and that's actually where the access controls come
yeah.
into the
Hmm.
picture. So if you basically offload the multi-tenancy to that layer, then you can actually effectively multi-tenant your database in terms of access control. So that when you write logic for it, it basically means whoever is that tenant, they can only see their own stuff, right? They can only modify their stuff.
Hmm.
But then you have to start pay attention to as you grow to things like do we need to like shard these tables, right? So for example, some tenants are big and some tenants are small. So I believe actually Nile does a lot of work in that direction,
Mm.
uh, basically
Sorry,
figuring out
does
how to shard it.
Postgres shard by row? So is
I
it
mean,
like, is it row based shards, or can you do like column based shards as well?
column you would have to do yourself, kind of,
Hmm.
very much yourself. But yeah, it's still like basically condition based, sharding.
Hmm. I
Yeah,
guess
like
you can
this part,
extract a column into its own table and then write a view that just joins it to pretend that nothing ever
Yes,
changed, and then shard
right,
that out,
right.
put it in a
Uh,
different table space.
but definitely multi-tenancy is not an easy problem. And there's actually an interesting topic of, I wouldn't call this research yet, I would say pondering. Um, and that is basically how do we define our schemas?
Hmm.
The problem that I see right now in our schemas, they are kind of at a wrong level of abstraction. They're basically saying, well, our schemas are the same as our tables, right?
Right.
That's what they encode. And even drop in the fact that they're very imperative, such as it's create table and this and that. So they're not actually declarative,
Hmm.
realistically speaking, right? They're prescriptive as to what needs to happen.
Right,
Let's
right,
ignore
right.
that for a second. They do not encode enough information to actually say much about it. Yes, there are foreign keys. That's kind of helpful. I mean, thank you, great. But for example, there's no notion of what are the consistency and availability zones.
Hmm. Never really thought about that part.
Because if you think about multi-tenancy problem, right? Like you, for example, don't need to have consistent, like basically consistent information about the other tenant from this tenant. They may never interact at all, or maybe they only interact sometimes. Well, you might want consistent, but it doesn't necessarily have to be available, etc. So you have to be able to define that,
Interesting. That's
and we
very
can't.
interesting.
Like we don't have a language for that, right?
Yeah. And I think the Postgres core itself, it's basically just, we just do replication of everything to everything.
Yeah,
So,
and that's not ideal.
hmm.
Um, but I mean, it's a very long-term thing. You cannot change this overnight. But we need to start asking ourselves a question: whether the schema definition language, for lack of a better word, should be rethought, because all these DDL statements, they're not declarative, and they're not addressing these sort of meta information that is actually critical.
Hmm.
Because once you say, "Oh, this is its own zone," and that can be by some keys, etc., saying like basically within this key, it's one zone, and they have to be consistent because well, it's for one tenant. But outside of it, doesn't really matter,
Hmm.
right? Then this whole notion that relation is always stored the way you define it is leading to problems. So, for example, a lot of people do not adopt highly normalized form
Yeah.
just because it's perceivably slower if you have a lot of them and you do select start from all of them. Like if you have to join all the small relations,
Hmm.
it is slow. But it's slow because we never really think about this problem. And so we don't have a notion of clusters of relations. So Postgres just says, well, this is a table, and this is a table, and this is a table, and this is a table,
Mm-hmm.
right? And for it, there's no meaning between them. Like there's no correlation between them. Whereas I can say, actually, well, think about a singular table, a really wide table, right? And you can have an index on it, like for the primary key, for example, just that, right? So
Mm-hmm.
simple
Mm-hmm.
stuff. And obviously, getting anything out of that table is relatively fast because you just do one index
Everything's
lookup.
just already there. Yeah, yeah, yeah.
It's just done, right? But it's not flexible enough, and if you do read out too much stuff, etc., right? And if you want to do a highly normalized form, you break that up, right? And so now you have all these individual tables, and now every single one of them has its own index, say for the
Mm-hmm.
same primary key, right? So in order to find everything, you have to like this key and this key, like basically index, index, index. Let's say we have six of them. So
Mm-hmm.
we
Mm-hmm.
look up the same index six times.
Mm.
But if at the schema definition level, right, we said, hey, this is a cluster of tightly
So
integrated
they all
notions.
belong, like they are separate tables, but they all describe entities in the same way. So you can like basically get away with just having like a singular index for all of
Right.
them. Is that what you're
But
saying?
that's exactly what I'm saying. So instead of index that says index and here's the location of this particular record, we do here's the same ID, but now it's a tuple of
Mm.
locations.
Oh, huh.
Because we
That's
know
kind of cool.
the size of this sort of domain or whatever
Right,
you
right, right, right,
cluster or whatever
right.
you would call that, right? I'm still trying to find a good term for this, but
Yeah.
this
No,
kind of thing,
that's really interesting. Because a lot of times, uh, I'm gonna bring it way from up that level to like a very very pragmatic application developer level. But when I was dealing with Rails, they would support what the hell did they call it? It's like some sort of not isomorphic, but basically you can describe, you can kind of have like a base class and descendant classes, and they map it
polymorphic relationships.
polymorphic, yeah, not
Yes.
isomorphic, polymorphic tables. But what they did is instead of segregating those columns that are per type, per child type into its own table, they would just make a bunch of that stuff nullable and put them all in the same table. And then when the data comes in, the ORM would kind of de-ambiguate what you actually meant and ignore. But like you don't want to have columns with nulls in your database if you want performance usually. Like if you extract it, then you don't have to store the nulls. You just don't have a record for that ID.
Right.
And Rails' ORM was not smart enough to do that. And that always pissed me off. It's like, you could just do a join. It's not that hard. Like, why do you have to create all this
Right.
extra garbage in this table that never is going to be populated for like 99% of it? You're like killing your performance. You're killing your indices because you're like shoving nulls into a bunch of things. It never made sense to me. So the thing that you're saying right now, I'm like, oh, where was that? However many
Well,
years
it
ago.
still does not exist.
Yeah, yeah, no.
Yeah, but
Unless you manually build it and you're going into limitations of scanning all these multiple different indices. I mean,
right.
the query planner is not that bad. And if you do the modeling correctly and you don't shove a bunch of nulls where they're not supposed to go, then it's still reasonably fast.
It's still reasonable. The problem that we still see that obviously select star from all the joined tables going to be ridiculously slow comparing to a
Mm.
wide table.
Mm-hmm, mm-hmm.
What I'm finding repeatedly so far is that there are very limited cases where people actually need select star from everything.
Or you could maybe do materialized views or something
Right.
like
And so
that.
when they do, it could be just a materialized view. And even, in certain cases, incrementally materialized view. And so,
Can you do
because
sharded
oftentimes you need this
materialized
for,
views, I wonder?
need to think about that. But basically, there are workarounds for this problem, like, view materialization, etc. But wouldn't it be great if we actually avoided this problem from the get-go,
Yeah,
right?
no,
So
that would be
reduce
really
the number
interesting.
of lookups. And this is what I'm trying to drive at. There are obviously, these examples like availability zones and the, sort of logical domains. Um, but they're driving back at the very same notion. The way we define schema, we always almost define them in a very physical way. Basically, how is it going to look like on disk, as opposed to the logical structure. And the whole relational theory was absolutely mathematical theory.
Mm-hmm.
It had
Yeah,
nothing
yeah.
to do really with the implementation of it, right?
With how the bytes are aligned on disk with
Yeah,
padding.
it just does not matter. I mean, math doesn't touch that, right?
Yeah,
So it's just
exactly.
it's a
Yet
theory, and
again, a beautiful abstract concept is ruined by the laws of physical
yes,
reality.
right. But it's interesting because it also again leads to very interesting things that I think have been tried before, and it maybe it's time now to start looking at again. So one of the ideas that I had a couple of months ago was kind of interesting. Think about an arbitrary limitation that I'll throw at you. Imagine if your columns did not have column names and they only
Okay.
had types.
Okay.
So having a table that has columns text, text, int, text is not very helpful
Not really, no.
because, like, what the hell is that? Right? But it drives you to define types that are effectively semantic. That is, they have meaning. So if you have like phone number, address as
Hmm.
types, right?
Yeah, so you're going toward what's the word I'm looking for? It's the thing that I always complain that TypeScript is lacking out of the box. It's like nominal types.
Yeah, I mean, like in Postgres, they call them domains. They're not perfect, but they're
Mm.
there, you know. And, well, some of them are just domains. Some are, say, composite types. Doesn't really matter.
I guess
And
in
those,
this case I was saying like nominal types in the sense like an address is a string and your last name is a string, but they're not interchangeable, even though they're both strings.
well, first that. And so basically, when you think about types like text, they talk about how it's represented on the disk, more or less, or in memory, you know.
Yeah, roughly.
They're structural, effectively. They're
Mm.
telling us that it has this sort of size and information,
So your column
layout.
name is a substitute for your semantic meaning.
Right, and usually it's just like a bunch of letters, in Latin alphabet because that's what's supposed to be, and that's it, right? Like there's very little way you can infer information from that
As
except for
the
reading
founding
it.
fathers intended.
Right. But the idea is that if you replace these structural types, that is, what it is in representation, to semantic types, it opens a few interesting possibilities. So one is, well, instead of just defining arbitrary types, we can start looking into ontologies. They're
Man, this is getting
like
so esoteric. I'm
I know.
barely hanging on to this thread. I'm like, this guy is like way out there. What is he even talking about?
No, but the idea, like, I mean, we'll not get into the deep part, but there are some databases that use WordNet, this database that maps English words, right, to
Mm-hmm.
meaning. And they basically built like relationships between words, etc., etc. So if you say temperature in Celsius, then there's an exact meaning to that,
Mm-hmm. Mm-hmm.
right? And what's interesting about that is that now we can actually start connecting schemas designed by different people together. Because right now it's impossible. Like
Oh,
software
okay.
sort of integrates, right? But databases never integrate. Like it's just impossible almost because
Mm.
we never really use libraries or anything, common type systems. We don't really do much of that, right?
Okay, I think I'm starting to kind of see what you mean.
Right.
It's
So
kind of
this
cool.
thing
Yeah,
is
yeah, yeah.
interesting, well, for integration purposes. The second interesting thing about it is because if you are actually using ontologies with all this, word databases and everything, that is actually a mapping of a vector, in that vector space, all this LLM conversation, right? So now every column has, a
Semantic
coordinate
tagging. Yeah.
coordinate in that vector space that your LLM will have, or whatever else you use, with that vector space,
You'll
like
have much easier
similarity
time
search.
dealing with it.
Right, because now we're saying exactly what it is. And so if somebody defined almost the same thing, we can actually see these points are very close. So the similarity search is, allowing us to say, oh, this is, very similar data. I might be able to handle it, in certain ways. And I think this is very interesting. And the third interesting thing here is that, well, what if we actually shed the idea that there should be a prescribed structural typing underneath it? So when you send data, you just save whatever form it came in. And you can then say, well, most of the time it actually came in as something that transforms to text of this format. And we can optimize for that. But working with real systems, like I had conversations with people like in healthcare, for example,
Mm-hmm. Mm-hmm.
data is never really proper. Like 95% of it is fine.
But there's a
Like
lot
for
of
example,
garbage in it.
but there's garbage and you don't want to dismiss that.
Hmm.
Because some of this, for example, your numbers might be still fitting into the numeric form, but in aggregate they don't make sense. Like certain readings of certain
Mm.
like blood tests, whatever, like the range of numbers doesn't make sense.
Hmm.
Like, but even by themselves, they might be fit in,
So
whatever,
is it an anomaly? Is it a misinput, or is it some medical phenomenon that never been observed before? How can you even
or like
tell?
equipment failure,
Or yeah,
is
exactly,
and
exactly.
sometimes they have like string, because instead of readings, a doctor or technician wrote something, something like a note. And so,
Hmm.
what do you do with that? And so the idea was like, if you have the semantic meaning and just start sort of shoveling all that data in and use computers for detecting patterns and optimizing for, types that are regular, but still storing the other ones. And then you can actually figure out what to do with them and improve your model as you go. So you focus more on the meaning of your data as opposed to, is it a varchar? Is it int?
Wow.
Because
I
for domain
am.
experts,
Yeah.
there's no varchar, there's no int.
Right. Right. Yeah. So you're trying to effectively like bridge different worlds because they can't really talk to one another because they're speaking different languages.
I
Like
think
this
so.
side speaks about ints and varchars, and this side speaks about concrete concepts, and it's really hard for them to get like a common
Right. And I think that
understanding.
this is where we got types wrong in databases, and maybe not even just in database, where computer programmers come in from their mindset. And
Mm-hmm.
I'm a computer
Mm-hmm.
programmer too. We heard the word type and we're like, oh, we know types.
We know what
Those are
types are. It's like, no,
integers,
you don't. Yeah.
floats,
Yeah.
like all these types. We know that, right? But outside of this little, well, maybe not so little world, types are completely different.
Hmm.
Like that abstraction of int, float, string, whatever is just absurd
So it's just
anywhere
tied
above
to
it.
how you represent it and store it, but it has no inherent meaning apart
No.
from that. I see what you mean. I think that again, I'm gonna take it from this level up here and bring it to the mundane development level. But this is why I find so much enjoyment in working with TypeScript because TypeScript actually makes it much easier to describe what you're talking about. Maybe once they have built-in nominals, that would be even better. But it's exactly like you're not operating on just strings. You're not operating on just integers. I think F sharp probably has a best way of dealing with that out of the things I've seen. Maybe Haskell, but I don't know enough Haskell to kind of say with
Yeah, I
any
mean,
degree of
the whole
confidence.
ML, Haskell family. I mean, F sharp
Yeah,
is effectively OCaml, right? So
yeah,
it's
pretty
ML
much. But
family.
like, yeah, like so they have nominal types, and the other cool thing that F sharp has is units of measure. Is that you can have like these like you mentioned like degrees of centigrade is
Yeah.
different than degrees of Fahrenheit, and C programmer would look at it and be like, "That's an int." It's like, are you sure about that? So yeah, I kind of sort of roughly vaguely see what you have in mind there. I think there's a lot of interesting possibilities, but if only as you said there was enough super smart programmers to actually implement all of these things.
It's not about just super smart programmers per se. I mean, we need
I think
smart
it's a
programmers.
conceptual shift in terms of
It's
how you
that's
even
exact
understand it.
basically just making the shift and making it somebody's mission to actually see this through. Whether it will actually see the light of the day and get adopted doesn't really matter. Because if you don't try, it will not happen
That's
for sure.
ultimately very aligned to doing what you find enjoyable and for fun and what happens if I try it kind of mentality. But
It does.
a lot of us in the development world are stuck on the stuck in a cubicle building boring business applications. We literally have no time to look up and see the stars in a lot of ways.
Yeah, the trenches, right?
Yeah, we're in the trenches. We're just like mining those bytes and pixels. The pixels are really hard to get these days, man.
Especially when they're not aligned vertically.
Yeah, exactly. Ever since they introduced those 4K screens, those pixels are really tiny now. It takes so much more effort to get them out of there. So
Yeah.
it's a tough life, man.
But I think it is necessary to try and develop the theory and the tools around that. There are still, amazing projects that are trying to explore the space. There are projects like uh, you know, that are trying to implement relational theory as it was meant to be.
Right.
in Haskell, of
I'm
course.
just thinking that like
But
computer science was probably way more interesting back in the days where LSD was still legal.
fair,
Because you can
fair.
really expand your consciousness and come up with all sorts of crazy concepts and try to like formalize them in form of math on a paper somewhere. But these days, everything's so boring. I'm just gonna
Well,
take it into a completely different thing. But you know how like 80s and 90s had very particular style of movies. Everything was like this
mhm.
huge action sequences, and a lot of people say that probably that was a lot due to the fact that half of the Hollywood, or maybe 90% of Hollywood, was just doing copious amounts of cocaine. So that was the kind of thing that made sense to everyone at the time. So now that
Right.
it's completely different mindset, they're making completely different movies. And same thing in computer science. Like we can't expand their consciousness nearly as much. So everyone's just building basic business boring applications, and that's where it's
Well,
at.
I think
So
it really depends where you are and where you want to be.
mhm.
I think, I mean, obviously, it can help some people, to use drugs and stuff to expand their
We're not
sort of the limits of
advocating
their.
for usage
We're
of
not
drugs.
advocating for that. Like, I'm not using those either. But I think it's like with anything. If you want to get better at something, you have to start doing it,
You
right?
have to,
Like,
yeah, start
like
accumulating the depth of understanding of the thing that you're
And
doing.
not just understand. I'm talking about simpler things. You remember me, many years ago. I was fat and lazy, right, and kind of sickly. But now, like, I run marathons. But you cannot start by just running marathons.
You
You
have to
just have to
arrive to
start
the
running,
point where you are willing to start to run marathons. And
right?
that's a conscious process that is long and arduous and rife with pain and suffering, and you kind of have to overcome a lot of things. Like before you even begin to be ready to start running marathons, you have to go through a lot of mental transformations to kind of
Right,
be
but
in
you
that
have to practice.
headspace.
At the bottom line, you just have to practice, however badly, right? So running, thinking out of the box, implementing things that you think you never have time for. Because if you have this mental block that, well, I never have time because I'm in the trenches. Well,
Right.
of course, you will never have time.
Yeah, that's true. It's a self-fulfilling prophecy in a lot of
Right.
ways. And I was
But
gonna say, but Yuri, there's TikTok and YouTube Shorts. They're just so much fun. I don't have to do anything. I
right.
just sit there and then do
I
this all
know.
day.
I sometimes fall into this trap too, especially shorts,
Oh
like
yeah,
it's
Shorts. It's crap, man.
but they are very time consuming. What I'm saying is if you want to be at a different level, higher, lower, it doesn't matter, right? Whatever you do,
Start moving there.
start moving in that direction, right? So if you feel like you're drowning in the bytes and pixels that you're mining, well, find like 5% of your time, right, to do something else. And like, will your first research or reading of a paper will it be great? Probably not, right? Like you probably will not achieve anything
Yeah.
substantial, but you'll move like this one
It's
little bit,
it's a theme
pun
from a
intended.
previous episode. It's like sucking at something is the first step of becoming sorta kinda decent at something.
Right. You have to start at the second point, you
Yeah.
know.
Yeah.
So that's what I'm saying. I don't know how to solve this en masse, and it's probably not solvable for everybody. Like, not everybody will want to even become somebody who's trying to think out of the box and come up with new ideas. In
Yeah.
fact, most people wouldn't want that because it's painful. It's not like, you sit down and I'm gonna invent some stuff and feel good about myself.
Yeah,
It's
sometimes
a painful process.
you have to have such an open mind that your brain is at risk of falling out. It's not
Right.
easy, right? And it really depends on your like personality type, whether or not you even have, compunction toward artistic creative thinking and having to just be not rigid in any way, shape, or form. So it has its own
Right.
constraints for every
I think
person.
I think there's a function for self-selection, and that is if you are bothered by the fact that you're just in the trenches and shoveling those bytes, right? That maybe you have this sort of compunction, to actually um, go and try something. Doesn't mean you'll get good at anything, but at least you
Well,
tried.
you won't get good at anything right away. You will get good
Right,
at something eventually, which
right.
is I
But
think
what
I
I mean,
think right now we're sort of in this state where everything's so trivially achievable or not achievable, trivially attainable at the basest level, it's immediately attainable right now. Like if I want to have some entertainment, I can open YouTube Shorts and I can have my entertainment right now. I don't even have to do anything for it. But in order to get good at something, that takes years, and people are just not willing to invest that kind of time, because I think they don't have an example in their own life a lot where that type of time investment gives you those kinds of results, and then you extrapolate it on other domains of your life and say, hey, if I spend a bunch of time and achieve this result here, I can do the same thing over there and achieve similar result, right? It's just not a, I don't know, again, I'm
I get
speculating,
that.
but it
Yeah.
feels like it's not even a thing anymore, because everything is just like, oh, no effort. Just, this is no effort, that is no effort, like
I
nothing
100%
requires a
agree
lot of
with this.
effort.
And getting good at anything, or passively good at anything, also requires not just time but actually pain, because you'll feel bad about yourself because you're still not good, right? So like, why
Yeah.
I'm sucking at it, right? And then you'll have self-doubt. I mean, not
Yeah,
maybe not
yeah,
everyone.
yeah,
I
yeah.
have a lot of self-doubt all
Oh,
the time,
all the
right?
time. Yeah, yeah.
um and even inventing something, as in like, I'm kind of seeing something there and I don't know what it's gonna be like. Just that process is mostly actually not rewarding.
Hmm.
It's painful.
You
You
know,
get some reward somewhere,
yeah, the
but
fact that the reward is very, very delayed is a very interesting thing. But I had a paradoxical thought just enter my brain, and I would say, parents, let your kids at least get good at video games because they can enjoy it, and then they can draw the parallel of spending all of this time getting good and being good and translating into something else, because at least they actually have fun doing it. And I don't know, it might work if it's steered correctly. I think
maybe.
it actually may be a good kind of thing to have in your life, because you have an example for yourself that you were able to do it by effort and spending time on it.
But I mean, I think this is a great point. You need to train for success.
Mm-hmm.
That is, basically, what does it even mean to achieve success, right? Like,
Is it your determination of success or somebody else's determination of
right.
what
Well,
success
games are
is?
usually not your own determination of success because, like, it's a
Well, I
game,
mean, you,
right?
you you can have a feeling that you're like definitely better than everybody in your
Fair,
lobby. That's already something.
right? Um, but what I mean is, I think it's a necessary component, but I think the other important component is that you basically have to set your expectations that you will never achieve anything. That is,
Mm-hmm.
you do this because you have certain variation of a calling. That is, you feel like you have to do it. And if nothing comes out of that, and that's kind of pure science, right? Because most scientific experiments kind of fail, right?
Yeah, yeah, yeah.
You should be okay with that.
Mm-hmm.
Like, start from the point, like, when they say when you're heading into a tough situation, assume the worst outcome and play from there. And so that anything better than that worst
Anything
outcome.
better will feel like a win, right?
Right. And so you start from the point like, I'm doing this research, I'm doing this exploration, whatever. And chances are, or even not chances, just tell yourself, nothing will come out of that. But
Mm-hmm.
I'm so drawn to it, I have to do it anyway. And that's also a good filter. Are you willing to do this work, knowing full well
That
that
is
nothing comes
likely
out of
not
that?
gonna amount of anything.
Yeah.
Yeah, yeah.
Like, it's
Well, I
basically
mean,
all going to be in vain,
it's kind of like what I do with this podcast. Like, I have no illusions that it's gonna make it big, but I do it anyway because I still have fun, and
Exactly.
we get to have a
That's a great
conversations like
example.
this. Yeah.
And oftentimes it's the process that matters, however painful, however taxing that process may be. If you're still drawn to it, then keep doing it. And if you're not drawn to it, scrape it.
Yeah. Do something else. There's so
Yeah. And
many
I think
things you can be doing with your life.
ultimately we're all gonna die, Ultimately, probably there's no purpose to anything. So just do something if you feel inclined.
Yeah, make your own purpose. You know.
Yeah.
Well,
Yeah.
always inspiring to have these conversations. There's definitely a lot to think about. I guess in being in alignment with modern podcasts of that nature is like, where can people find you on the internet if they want to read your stuff, where they can play around with the things that you build? I'll put all of
Sure.
those links in the description somewhere.
Yeah, there's my personal website, yrashk.com. I'm still not very good at being uh,
Consistent.
prolific at writing. You can find me by my name on LinkedIn. I am kind of prolific there right now, just for whatever reason. LinkedIn became a professional social network.
Well, if
And
you put in good quality, at least it offsets all the AI slop and all the random garbage that people post on
yeah,
that
I'm
site.
posting
Yeah,
something that I actually write there. So you can find some of my writings there. You can find Omnigres by going omnigres.com, for example, or just find it on GitHub. So that's where most of my work is these days. Yeah, LinkedIn, Twitter, but I'm barely using it these days.
fair enough. Fair
So
enough.
it's kind of fading out
Yeah.
after 20 years.
Yeah, that's true. Well, Yuri, always a pleasure. Thank you so much for taking all
Likewise.
of this time. For everybody who's still with us, this is probably the longest episode that we have on record so far. So if you're still here, that's amazing, and we'll see you in the next one. Thank you and goodbye.
Yeah, bye.